Which ones did you want to see, do, go over, have questions about? Show me on your hands. I saw a lot of threes. If you had a 3, put your hand out. If you had something other than a 3, keep your hand up. And then I saw 2 and 1 were the majority. So we'll do 1, 2, 3. I give you at 17 or 18?
17.
Okay, that's good. Alright. For number 1, 1 less than twice a number. Less than is that turnaround phrase, which means it goes to the end. And then twice a number, pick a variable and multiply it by 2. So that one cannot be done in Desmos. That's something you have to know. You have to know the how to translate the words. Evaluate. Put these in for x and y. 3 times -1 squared minus 3 squared. Use parentheses, especially if you have a negative. That way the negative and the square don't mess up your answer. You can put this all in the calculator at once or do it step by step. So this would be 3 times +1 minus 9. So -6. And I'll show that one in Desmos here in a moment. And then number 3, if we distributed and then combine like terms, we get 7x minus 6 equals 7x plus 30. From this line, we can see that it's going to be no solution because we have the same coefficient but 2 different constants. So you could stop there, say it's no solution, or you could keep going, get rid of your variable terms, and see that you have 2 different numbers. -6 does not equal 30. Questions on any of those before I show you in Desmos how you can do those? When you're doing the ones in Desmos, remember that you can put did work in Desmos. So for number 2, you can do this one of 2 ways, exactly as we did it. Type it in with the numbers in parentheses. And it'll give you the answer. Or you could type it in, I don't think I can do this lowercase, but I'll try it. No, okay. So if you type them in with the variables uppercase, if you typed in lowercase for any other variable except x and y, this would work, but x and y, because those are what Desmos used to graph things, it won't let you do that. But if you type them in as capital letters and then as sliders, you could change the values to -1 and 3. And then it would put those 2 numbers in and solve it for you. So you could do either way. And then for the last one, because we got no solution, if you type all of that in, nothing would appear. So you have to type in both sides separately. And you can see that these 2 lines are going to be parallel. They have the same slopes, different line intersects. They never intersect. So there would be no solution. Now it does look like they're overlapping now, but that's just because it's really zoomed out. Questions on any of those? We are starting our next lesson on substitution. Don't you have those notes in front of you? And go ahead and copy down this definition. So for substitution, a method of solving systems of equations by substituting equations within one another. That is the definition of the substitution method. And then to solve one equation for x or y, substitute this expression into the other equation, solve for the variable, substitute your answer into the revised equation from step 1, or just an equation, and then solve for the other variable. So it's a lot of solving, substituting, solving, substituting, solving. If you have an equation like this, where both are already solved for x or for y, the same variable. You don't have to solve for x or y, that part is checked off. But then you have a choice. You can either substitute, you don't have to draw this next part, this expression into this other equation, where y is, or the second expression into the first line. So you're going to take one part and put it into the other. It doesn't matter which one you do, because regardless, it's going to look something like 4x minus 1 equals 2x minus 5. You write that part down. Or vice versa. And then we solve this like a normal problem. So how would we solve this? How could I solve this for x?
Subtract 2x.
Subtract 2x on both sides, and then I could add 1 on both sides. So we have 2x equals negative 4. Divide both sides by 2. So that x is negative 2. But unlike when we were solving these equations, because we're solving systems, if we are, when solving systems, in order to get a solution, we need an x and a y. We found part of it. So now we have to take that x and put it back into one of these equations. It does not matter which one. You could choose. Let's say I did the first one. So I would put y equals 4 times negative 2 minus 1. And then figure out what y is. And then you would write those two numbers as an ordered pair, negative 2, negative 9. And that would be your answer. So all the check methods from before, taking the solution, putting it into both of these, see if they work, that will still work here. As well as these are both solved for y, so you could graph them and see if that works. Or put them into decimals. You still have to show this work algebraically, but you can use any of those methods to check yourself while you're practicing. You have any questions on this so far? For number 2, we have one equation that's solved for y, but the second one's not. You have two choices here. If you like doing the work like this, like what we just did, setting them equal to each other, you could solve this equation for y and keep doing that. Some of those you will create extra steps. So the second option would be to take this expression, the 6x, put it into the second equation where y is, and you're going to rewrite it. So it'll look like 2x plus 3, parentheses, 6x equals negative 1. You're taking one expression and putting it into another. So we kind of did this before when we were solving equations. We just didn't call it substitution, but that is what we were doing. Then we could solve this. So combine like terms, divide both sides by 20. What is the value of x? And then, just like before, take that value, put it into, you can really use either or, but the one that's already solved for a variable would be the easier of the two. So that y would become negative 6, and your ordered pair would be what?
Negative 6.
So your ordered pair, that y would be negative 6, but what would the final answer be?
Negative 1 and
Negative 1, negative 6. Have any questions on how the substitution works? Right. 3 is going to be just like 2, but you're doing a little bit more. Taking that expression, putting it into the other equation where y is. The biggest thing with this is putting it into the right place. If you substitute and you have 2 different variables still, you know you did something wrong. Or something is wrong. And then go ahead and start to solve that one. When we combine our like terms, how would we solve this from here? Subtract 72 on both sides. So we have 11x equals negative 77. And then divide. And then take that, put it back into the other equation to find y. So that the y value is 2. And we would write negative 7. What's different about number 4? We don't know what y is, but what do we know? What x equals. That doesn't matter. As long as you have one of the equations solved for x or y, it doesn't matter. You don't have to have y. So now that we have x, we're going to do the same thing. The process is similar, but instead of putting it into y, we're going to put it into x for the other equation. So that would look like 2 times in parentheses 4y plus 7 minus 6y equals 12. And then we could solve it. So 8y plus 14 minus 6y equals 12. combine our like terms and solve. And then put your y value back into your x equation. What would your x value be? 3. So even though we solve for y first, still put it as an ordered pair x comma y. So 3 negative 1. Once you are finished with that one, turn it over to the next page, or to the back. Do we have any questions on how substitution works so far? What's different for number 5 than the ones we've been doing?
We have to find the
We have to solve one of the equations for a variable. We need to come back to that. So you have a choice. You can really solve for any of these variables in either equation, but to make your lives easier, if you solve for the variable that's by itself or that has a negative in front of it, you won't have fractions. So if you were to solve for any other variable, you're going to end up with an equation that has fractions, and then you have to substitute that equation with fractions, and then you're going to have a bunch of fractions. So you can do that, you just got to be careful. Or you could just solve for the variable that's by itself. How would we get y by itself? Subtract 2x. So that equation would become y equals negative 2x minus 2. Once you have one of the variables solved for, the rest is the same. Substitute it into the other one, solve for that variable, substitute that into the other equation, and then solve. So let's take this expression, put it into the second equation where y is, not the one we just solved. So that would look like 5x plus 3 times negative 2x minus 2 equals negative. Solve for x. As I'm doing this up here, you should be trying it on your own and then checking to make sure that you're on the right track, not just copying down all of my work. Once you find x, go ahead and find y. With this, you have choices. You can put it into the original 2 or the one we just found. I'm sorry, the one we solved for. It's up to you. But the easiest one would be the one you solved for. We should get 2 negative 6 as our solution. Questions on that? want to show you what a special case would look like. And then any you guys want to see to go over, and then you'll have time to practice. So there are 2 special cases on this page, 7 or 9. I'll let you guys choose which of those 2 you want to see.
Seven.
7, okay. For number 7, which variable would be the easiest to solve for? X in the first one, because it's by itself. So to get this x by itself, we would do what? So we have x equals negative 5y plus 4. And then we can substitute that into the other one, where x is. So that would be 3 times negative 5y plus 4 plus 15y equals negative 1. Go ahead and distribute. And when we combine like terms, what happens?
The 15 ones cancel out.
The y's cancel out, they become 0. So we have 12 equals negative 1, which is what type of solution?
No solution.
No solution. So you'll realize early on if it's going to be a special case, no solution or infinitely many, because your variables will cancel. I will advise that you be careful because you could accidentally get that if you, let's say, solve this equation, but instead of putting it into the other one, you put it back into the same one you solved for, and the variables would cancel again. And you would accidentally get no solution or infinitely many. I will also say, if you are solving and you get no solution or infinitely many solutions, you can't magically get a solution. You can't magically bring out an x and a y. That's not how that works. But also vice versa. If you start solving and you get an x or a y, you're not going to get no solution or infinitely many. It's one or the other. Okay. Are there any others on this page we want to see, do, go over, have questions about? And I think that's a good amount. That way you still have some to practice in your own. Alright, so starting with number 8, what would be a good variable to solve for here? X in the first one. So this is by itself. So do that very similar to 7, get rid of 4y by subtracting. You can put the plus 0, you don't need it though. What's our next step? Plus 2. What would we do now that we have that equation by itself, or with the variable by itself?
And then we're going to 4y x in the other equation.
Put this into the second equation where x is. So we have 3 times negative 4y plus 2y equals 20. And you can not distribute, but multiply and then combine the terms. So we have negative 10y equals 20. Divide both sides by negative 10 so that y equals negative 2. and then take that number, put it back into your x equation. So that your solution would be 8 negative. Number 9, what would we be solving for?
The single.
The single y in the second one. How would we get that y by itself? Subtract 2x on both sides. So y equals negative 2x plus 18. Take that equation, put it into y of the first. That expression, put it into y of the first equation. So we have 6x plus 3 times negative 2x plus 18 equals 54. Distribute. What happens when we combine our terms? It's going to be infinitely many solutions. These cancel, leaving this 54 equals 54, which is a true statement, so infinitely many solutions. You can use IMS or the infinity symbol. So then for the remainder of class, you'd be working on one of 3 things. The rest of the problems on this page, the delta math on this that is due today, so the solving by systems. If you did not finish the delta math solving by graphing, that is also due today, you'll be working on that. So you have 3 different things to be working on. If you finish all 3 and want more practice, there is some on the back shelf behind there. I'll be calling up the last people I still need to talk about recommendations. You guys can work together, move around, let me know if you have any questions.